Mom, what are you choosing?
Mom is choosing the type of the coffee that we want to buy, dear.
Do you always drink coffee, Mom? As I know, isn't coffee bitter?
Of course, I love to drink coffee because of the many functions and nutrients contained in coffee, even though its taste is a little bit bitter.
How is coffee made, Mom?
Let's see. Alright, coffee is made from the coffee beans that has been roasted and it has been grounded into a fine coffee powder, such as this one.
But why are there so many different types of coffee?
Okay, so this is one of the reasons why I love coffee. You know, after the original coffee powder is produced, many additional flavoring ingredients are added to make the coffee taste more appealing, such as it will not be too bitter. Do you understand that?
Now I get it. What ingredients are contained in coffee?
Alright, darling, you have a good question there. So I will explain a little bit about the ingredients. Okay, in coffee, there are many organic compounds including caffeine, tannin, thiamine, xanthine, spermidines, and spermines, glycol, citric acid, chlorogenic acid, acetaldehyde, butyrosine, and scopolamine. Do you got it?
Wow, there are many organic compounds contained in coffee.
Yes, my dear Timmy. Alright, later you will learn more about coffee in school. But now let's pay for these groceries and go home. You know that I'm hungry. So let's hurry.
Yes, Mom. Good morning, everyone. Good morning, Mr. Crocker. Today, we will learn about coffee. Do you all know the origin of coffee? No, Mr. Crocker. In the commercial coffee industry, there are two important coffee species, which is Arabica and Robusta. Coffee Arabica is descended from the original coffee trees discovered in Ethiopia. Meanwhile, most of the world's Robusta is grown in Central and Western Africa, parts of Southeast Asia, including Indonesia and Vietnam, and in Brazil. In coffee, there are also many organic compounds. Among them are acetaldehyde and amines. This is an example of reaction mechanism of acetaldehyde. So we start with activated chromic acid because it accepts a proton and has a positive oxygen on one of the carbonyls. This makes chromium even more partially positive, and oxygen being partially negative will want to attack. That will show oxygen reaching out with a lone pair of electrons to attach that central chromium, giving it too many bonds. As a result, the bond between chromium and the activated oxygen will collapse onto oxygen. The oxygen that attack now has 3 bonds and one lone pair of 4 formal charge of plus 1. We have to get rid of the electron, and we show an internal proton transfer where one of the hydroxyl groups on chromium will reach for that proton, giving the electrons back to the oxygen atom. Now chromium has a positive oxygen. Oxygen on our starting molecule now has 2 lone pairs and is back to being neutral. This intermediate is called the chromate ester, and for ester, remember, has a carbon double bond oxygen and a single bound to an OR group. So next step is to break away the oxygen from the chromium, and this is allowed to happen because we have at least one alpha hydrogen. The alpha carbon is the one that is holding the oxygen. The hydrogens attached to that are the alpha hydrogens. So we show a weak base in solution like water coming in to grab the hydrogen atom, but it only grabs the proton, leaving the electrons behind. Instead of collapsing the electrons on the carbon, we collapse them towards the oxygen atom. The two electrons will now sit between carbon and oxygen as a pi bond. Next is oxidation step, where it is to form a second bond between carbon and oxygen. In this case, to form the aldehyde, however, oxygen has too many bonds, so we have to kick out the bond between itself and chromium, collapsing that onto the chromium, and this will give the product of aldehyde. If acetaldehyde undergo further oxidation, carboxylic acid will be produced. So functions acetaldehyde in coffee is signaling molecules experience unfavorable acute consequences as a result of acetaldehyde accumulation. For instance, acetaldehyde, which is usually associated with the body's flight or flag reaction, frequently causes cardiovascular systems like palpitations, which is citation. This is why you could feel anxious, sweaty, and have a racing heart the day after drinking. Acetaldehyde also causes your blood vessels to dilate by increasing the synthesis of histamine and bradykinin, aka vasodilation. Flushing and an increase in skin warmth are common signs of this.
Okay, so for the second example of the reaction mechanisms that happens in coffee is amide. So here I will explain about these mechanisms first. The first step of the Maillard reaction is a sugar amine condensation reaction to form an N-substituted glycosyl amine. The carbonyl group on the glucose sugar root, which is the C double bond O in the red color, reacts with the amine group, the NH2 in green color, in a protein or amino acid in food to form an amine bond, which is in the pink color, in the N-substituted glycosyl amine, together with the water. So here we will notice that the sugar or the glucose reacts when it is in an open chain form. The mechanism for the first step of the Maillard reaction involves the nitrogen lone pair from the amine group attacking the electrophilic carbon atom on the aldehyde carbonyl, which is the C double bond O. The electrons are pushed from the double bond onto the oxygen atom, giving it a negative charge. A proton is then transferred from the positively charged nitrogen to the negatively charged oxygen atom to form a hemiaminal, which is in pink color. The oxygen atom then donates its lone pair to a proton, forming single bond to OH2+, which is a very good leaving group. Then finally, the nitrogen can donate its lone pair to form a new C double bond N bond of the amine in the N-substituted glycosyl amine, which is in the process it takes out the H2O as the leaving group. Then we move to the next stage, which is the next stage is the Amadori rearrangement. The second step in Maillard reaction is Amadori rearrangement, which is a spontaneous reaction even at the temperature as low as 25 degrees Celsius. The Amadori rearrangement is an isomerization reaction, which is the N-substituted glycosylamine 1 to a nominal N the Amadori compound all have the same chemical formula with the other that will result in the formation of ketosamine called the Amadori compound. This will contain both ketose, which is a sugar bearing a ketone, and an amine. The isomerization reaction, or it also called an amine tautomerism, that occurs between the N-substituted glycosylamine and 1,2-enominal is reversible. The nitrogen atom in N-substituted glycosylamine will donate the lone pair of the electrons to a proton, forming a new NH covalent bond. By following this, the two electrons in the CH bond, which is in the pink color, are donated to form a new carbon-carbon double bond, and it will push the electron in the C double bond and onto the positively charged nitrogen atom. The second reversible isomerization reaction occurs between the 1,2-enominal and the Amadori compound, and an example of ketoenol tautomerism. In the forward reaction, 2 electrons of OH oxygen in the 1,2-enominal are donated to a proton through the CC double bond, and this is followed by deprotonation. Then the further reaction, the Amadori compound that can then react to form several different products, including hydroxypropanol, which is C3H6O2, and all of which can react again to form even more products. The products that are formed depend on whether the reaction mixture is alkaline or acidic. As example, hydroxymethylfurfural, which is the structure is C6H6O3. So this is a complicated process which that can we conclude. So here the function of the amide is as the regulation of the growth and blood pressure, and to control of the nerve conduction in the body. Do you all understand that?
Yes, Mr. Crocker. Okay, good. Now, can anyone tell me 5 functions of the coffee? Me. First, weight loss and prevent weight gain. Yes, correct. It is possibly because of suppressing the appetite and temporarily reducing the desire to eat. Okay, next. Second, increase attention and alertness. Third, it can lower risk of Alzheimer's disease and Parkinson's disease. Fourth, to improve physical performance during endurance exercise. And lastly, it will help to boost long-term memory. Wow, very good, Timmy. But it also have harmful effects of coffee, such as anxiety and depression, high blood pressure, insomnia, headaches, dizziness, dehydration, and jitters and shakes. So always drink coffee in moderation. Understand? Yes, Mr. Crocker.